So in Blaisdell circle notation, you can do addition, multiplication, exponentiation, tetration, and many more than that with the two equations that have already been shown. But you can also do subtraction, division, roots, and logarithms. And there's two equations for those. So x, n, y, half circle, n, y is equal to x. And x, n, y, half circle the other way, x is equal to y. Now with this, knowing that x1y is equal to x plus y, and x2y is equal to xy, and x3y is equal to x to the y, and so on, you can use these to derive what x half circle 1y would be equal to. So, if you take this equation and put 1 in, x1, y, half circle 1, y is equal to x, that means that x plus y, half circle 1, y, is equal to x. Now this can tell you that x half circle 1y is equal to x minus y, because x plus y minus y is equal to x. And if you do the same thing with the half circle the other way, you get that it also equals x minus y. So x1 half circle the other way, y, is equal to the half circle that way. And x half circle 2, y, is equal to x half circle the other way, 2y, which is equal to x over y. So half circles are the anti-function, or anti-operation, or arc function, any of those words, of the full circles. Now, why is there a forward circle, a half circle, and a backwards half circle, if they're both the same thing? Well, it turns out that they're only the same thing for the first two. They're different for 3 and above. So let's try that. Let's try this one. X, 3, y, half circle, 3, y, is equal to x. That means that x to the y, half circle 3, y, is equal to x. Which means that x half circle 3, y, is equal to the y root of x, because the y root of x to the y is equal to x. So plugging in this operation here makes this whole thing true. So you know that x half circle 3 is equal to that. But what about a half circle the other way? Let's try the second equation. X, 3, y, half circle the other way, 3, x is equal to y. So x, y, half circle the other way, x is equal to y. Now, knowing this, you can find that x, 3, half circle the other way, y, is equal to the log base y of x. Now, if you take the log base x of xy, that's equal to y. So, the half circle one way for 3, y is equal to the y root of x. But a half circle the other way is equal to the log base y of x. So you might be wondering, if it's log base y here, why is it log base x here? Well, that's because in this case right here, the y is the x and the x is the xy. So the xy goes where the x is and the x goes where the y is. So the x and y are completely different variables in here than in here, but they're still used. And the reason why there is the same anti-function for these two and not for anything past here is because x and y is equal to y and x only if n is less than or equal to 2, or if x is equal to y. So if you have x plus y, that's equal to y plus x, which is substituting a 1 in for n, and xy is equal to y x. But x to the y does not equal y to the x. So that's why there's two different anti-operations, and they're the same for 1 and 2, but for 3 and above the anti-operations are different. And this is how you define the anti-operations in Blaisdell circle notation.